Hi there, my name is Antonio Feregrino, and today I will give you some good practices to develop your data science projects to make sure they are maintainable and easier to put in production. These good practices have been tested over and over again, and some of these lessons were learned the hard way. Number 1. Store data, artifacts, and code in different locations. A data science project generally has three types of files. The first one is data, all the raw input data and any intermediate data results. For example, CSV files, database dumps, engineered features, and so on. Artifacts. Any other file generated during a pipeline execution. The most common one is a trained model, or an encoder that has been fitted to our data. They could also be a performance report or a file with feature importances. And the last kind of file are source code, all the files to support the pipeline execution. Saving everything in a single location tends to become messy over time. A good practice is to create a folder structure where all the boundaries are easily distinguished. Number 2. Declare paths and configuration parameters in a single file. Your pipeline might need to load this raw input data from different systems, such as a data warehouse, an object bucket in the cloud, or even an API. But not only that, for sure you will need to store some results, whether that be in the local file system or somewhere else in a remote storage. A common anti-pattern is embedding these configuration parameters in the source code. This is what we call hard coding in the software world, and it leads to the following issues. Ambiguity. Not disclosing external systems hides essential implementation details. This can confuse collaborators, prompting questions that could be easily answered if all this information was centralized. It also causes opacity. If there is no single place to know your data sources or your active or storage location, each collaborator might try to fetch data from where they understand best, risking the quality of their work without them knowing. And what if they put the artifacts in the wrong place? What if they fetch data from an old, outdated database? Another problem is redundancy. Infrastructure resources are likely to be used multiple times. If every collaborator creates their own, we may end up with duplicated services, driving our costs up and wasting compute resources. Remember, try to have a single file where you store all the configuration and then pass this configuration file around to the process that needs it. Number 3. Store credentials securely. Whether they are database credentials, access to our Git repository, or the login information to our S3 bucket, never store this information in a plain text file. You should make use of tools that are made to store credentials and only pass them externally to your source files when needed. For example, using environment variables. Another possibility in Python is that you could use the keyring library to manage your application secrets. A package such as keyring uses your operating system credential store, which is safer than a plain text file. In short, a git ignore file is a file where one specifies the kinds of files that Git should ignore when looking for changes in our repository. Missing this file can make your repository unnecessarily bloated, and in some cases it might break the project for your colleagues if you're committing things that are exclusive to your local environment. You might be asking, what should I include in my git ignore file? Well, a good start could be to grab the Python template for GitHub. This one contains pretty much what you need to get started. Then, make sure you also include common extensions to avoid accidentally committing data or configuration files. Keep in mind that git ignore will be used for any future commit after it is modified, so you might have to reset your state changes. And use specialized tools such as BFG to remove files from a repository history. Number 5. Automate the data workflow end-to-end. A data project usually requires multiple data transformations that are performed sometimes by different scripts or code. Automating the entire process is essential to ensure we have a process that is reproducible. Not having a fully automated analysis will cause trouble down the road. Here is where Ploomber comes in. It makes it easy to automate data workflows, adding as many scripts or notebooks as you want, defining these workflows in advance. Then you can execute everything using a single command. Number 6. Declare software dependencies. Data science projects usually depend on third-party packages, things like NumPy, Pandas, scikit-learn, and several others. Failing to specify which packages your code depends on will cause trouble to any new collaborator. It is a great practice to document all the dependencies so that anyone can quickly get started. In Python, you can achieve this via a requirement.txt file. This file contains a line for each package that your project needs. If you're using Ploomber, you can use the following command. It will take care of setting up a virtual environment and installing all the declared dependencies. Number 7. Split production and development dependencies. It is good to keep the number of dependencies at a minimum. The more dependencies your project needs, the higher the chance of running into installation issues. A way to simplify your installation is to split your dependencies into groups. The first group are packages required to run the pipeline. These are the packages that your pipeline needs to run in production. A second set of dependencies are optional packages that are just required to develop the pipeline. These are optional packages, as I said. You need these to work on the project, for example, to test the pipeline, to create documentation, running exploratory notebooks. In the end, they are not needed in production. There is a simple way to keep these dependencies separated, just use two files. The common approach is to have a requirements file for production and another one for development purposes. Then you can use a tool like pip to install them separately. Here is where I want to make note of something very important. When running in production, it is essential to declare the specific versions for each package you install. If you need a hand, again, you can just use Ploomber. Execute Ploomber install. This will generate two files, one for production, another one for development, each one with the specific versions of each package. Number 8. Have an informative and concise README. The README file is the entry point for anyone using your data pipeline. In this file, just make sure to include the basic information about the project, such as the name, a brief description of what it tries to achieve, the list of data sources, and of course, how to run the pipeline end to end. You have heard me mentioning Ploomber a handful of times so far, so I would like to remind you to follow us across all social networks, as well as invite you to keep an eye on our blog where you will find more insightful content just like this one. We have a Slack group where we would like to hear your opinion on this checklist. Now, let's go back to the good tips. Number 9. Code documentation. As new contributors join the project, documentation becomes more important. Good documentation assists in understanding how the different pieces fit together. Furthermore, documentation will be helpful for you to quickly get the context of a code you wrote a while ago. However, documentation is a double-edged sword. It will cause trouble if it's outdated. So, as a general recommendation, keep your code simple enough with the usual stuff. Good variable names, small functions, and very clear logical divisions. Having these will go a long way in terms of documentation. Others will be able to understand a great portion of the code just by reading the source, and then you can just get away with having minimal documentation to support the rest. Number 10. Organize your repository in a hierarchical structure. As your project progresses, your code base will grow. You will have code for exploring data, loading, generating features, training models, validate the model, and so on. It is a good practice to spread this code in multiple files. Multiple files means you will have to put a bit more effort in organizing them. It is best to organize your source code in folders, sometimes even following a hierarchical structure. Number 11. Package your code. Whenever you run pip install, Python makes the necessary configuration adjustments to ensure your package is available to the interpreter, so that you can use it in any Python session using the import statements. You can achieve the same functionality for your utility functions by creating a Python package. This gives you great flexibility to organize your code and then just import it anywhere. Creating a package is not that complicated as you might think. We have a blog post about it, and I highly recommend you check it. Number 12. Keep your Jupyter notebooks simple. Notebooks are a fantastic way of interacting with data, but they can get out of hand quickly if not cared for. It is easy to copy-paste code among notebooks and create big monolithic notebooks that break at the first wrong input. Again, allow me to refer you to Ploomber's blog, where you can learn more about how to use them. Number 13. Log instead of print. Logging is a fundamental practice in software engineering. It makes diagnosing and debugging much manageable. The problem with using print is that by default it sends the message to the standard output. If your code has a few print statements that execute for every record you process, your terminal will end up with so many messages that it would be impossible to see through the noise, rendering all the messages completely meaningless. A proposed solution is to use the logging module instead. Using a logging library will allow you to filter messages by severity. You can see when each event happened, including the file name and the line where the logging call was originated. And also, a good logging system allows you to understand what is going on in your system. Once configured, logging is easy to use. Number 14. Test your code. Testing data pipelines is challenging, but it's a great investment that pays greatly in the long run, since it allows you to iterate faster and with confidence. It is true that a lot of code will change during the experimental phase of your project. Code and test might become obsolete, but believe me, testing will help you make more consistent progress. We have to consider that data science projects are experimental. Validating the feasibility of a problem is usually the first step, but also keep in mind that a complete lack of testing might get you to the wrong conclusion. At a minimum, just ensure that your pipeline runs end-to-end every time you merge into the main branch. We have extensively written on testing for data projects. Check our articles on testing for data science projects and machine learning projects. Number 15. Take care of code quality. People read code more often than they write it. To make your code more readable, try to adopt and enforce a style guide. Style guides are about consistency. They establish a standard set of rules to improve readability. Such rules have to do with maximum line length, white space, variable namings, and things like that. The official style guide for Python is called PEP 8. PEP 8 is a lengthy document that might be confusing for people. But don't worry, don't get discouraged. There are tools that help you with its implementation. One of them is Python Style, which is a tool that automatically checks your code against PEP 8's rules. It will scan your source files and show you which lines of code do not comply to the standard. Another tool is PyFlex, which is a tool that also checks for possible runtime errors. It can find syntax errors or undefined variables. There is a way to use both of these tools at the same time, and that's through the package Flake 8. It combines both tools, and it comes with nice utilities to improve your code. There are other linters available. One of the most popular ones is PyLint. It's similar to Flake 8, but it provides a more sophisticated analysis. In addition, there are some other very specific tools, such as Bandit, that focuses on finding security issues, and iSort, that sorts your imports in a consistent, deterministic way. Number 16. Delete dead and unreachable code. Make it a habit to remove dead code, that is, dead code whose outputs are never used. There is also something called unreachable code, code that is never executed. An example of dead code happens when we call a function but we never use their output. In this example, compute statistics is dead code, since we never use the output, stats, so let's just remove it. We got rid of the function, but we should check if we're using it anywhere else. If not, we can just remove the definition altogether. It is essential to delete the code on the spot, because the more time it passes, the more complex it is to find these kinds of issues. I hope these suggestions help you improve your data processing workflow. Once you get used to them, you will see that keeping your code base in a maintainable state increases your productivity in the long run. Join our community on Slack to keep the conversation going, and follow us in our other social channels, where you will find more valuable information about data science and all the processes that aim to make it better for everyone. See you in the next one.